Momentum is the product of an object's mass and velocity. The law of conservation of momentum states that in an isolated system, the total momentum of these systems will always remain constant. For example, in this diagram, the balls are traveling in two different directions. The objects then collide and change velocities. However, the total momentum in the system does not change. P represents momentum, and the apostrophe-like symbol, also known as prime, is used to distinguish the momentum of the objects during different times. For example, P prime represents the momentum at the time of collision, and P double prime represents the momentum after the collision. All of these momentums are equal due to the law of conservation of momentum. Our first example is of an elastic collision. In an elastic collision, the total kinetic energy is conserved alongside the total momentum. The two baseballs are relatively elastic, and when they collide, very little kinetic energy is lost. We found that the majority of the momentum in this collision was in fact conserved, with a percent error of 5.4%. The initial momentum was 0.1927 kg per second, and the final momentum was 0.18 kg per second. Momentum was not completely conserved because the system was not completely isolated. Friction between the balls in the air as well as between the balls in the table both would have lowered the total momentum within the system. Furthermore, we did not account for momentum within two dimensions, as any movement forwards or backwards would have been lost in our calculations, therefore lowering the total momentum more. Through our calculations, we were able to determine that this collision was fairly elastic because a low amount of kinetic energy was lost. Our initial kinetic energy was 0.1012 joules, and our final kinetic energy was 0.080 joules. This left us with a loss of energy at around 21%. In the real world, collisions are almost never completely elastic. In most cases, some of the kinetic energy is converted into sound energy or thermal energy during the collision, and this certainly happened here. This collision, on the other hand, is far more inelastic than the first. Because the soccer cushion is soft, the baseball is able to put a small dent in the cushion, which takes away some of the kinetic energy. Because some of that kinetic energy is lost here, the collision is inelastic. However, regardless of the elasticity, the total momentum within the system is still conserved. Once again, our calculations showed that the majority of the momentum was conserved. We had an initial total momentum of 0.0745 kg per second, and a final total momentum of 0.0697 kg per second, leaving us with a percent error of 6.45%. Again, because of our calculations did not account for friction or movement within two dimensions, our momentum was not completely conserved. Compared to the last collision, this one was far more inelastic, with 52.9% of the total kinetic energy being lost after the collision. Our initial total kinetic energy was 0.0177 joules, and our final kinetic energy was 0.00834 joules. As with the last collision, kinetic energy was being converted into sound energy and thermal energy. However, with this collision, some kinetic energy was also lost in changing the shape of the soccer cushion, which is why this collision was far more inelastic. Please like, subscribe, and comment down below for more physics content. We'd also like to give a shout out to our #1 donator on Patreon, Mr. Gilowitz. Thanks for making these videos possible.